I think we are ready to go. As I said, good morning, good afternoon, good evening, everybody. Thank you so much for spending a little bit of time on your Wednesday with Automox. Today, we are talking about the TCO of automated cloud native patch management. Let's get started. So who are we? On the left, you have myself, Richard Mellick, Senior Technical Product Manager. On my proverbial right, we have the wonderful, beautiful Jay Goodman. Jay, say hello to the beautiful
Hello,
people.
everyone. Thanks for having me today.
Yeah, Jay is going to be doing my demo. So I'm going to be up here singing and dancing up for you, but he's really going to be doing the technical stuff, kind of showing off some of the aspects of what we're talking about. But he's also here to answer some of those technical questions that you might have. And so again, if you have any, go ahead and throw them up in the questions box. It's kind of a strange time, isn't it? We're facing an unprecedented time in this whole workforce. And each and every one of us has had to adapt to this brand new environment and the challenges that have come along with it. It does not look like this is going to be changing anytime soon for anybody. As a matter of fact, as we look through the global news and headlines today, beyond some of the obvious, many organizations are reporting that they will be adopting a remote workforce policy for the long term, meaning that this shift is here to stay. Now, this is an evolution, not a revolution of the workspace. The short-term efficacy of using remote work policies to reduce COVID-19 exposures is certainly vital to business continuity in the face of this pandemic, but so is keeping your team safe during this period. That's a no-brainer. And making sure that their remote endpoints are secure, well, that follows very close behind that. But with these changes come a list of concerns and issues that many organizations just were not ready to address, sometimes highlighting legacy support policies and even out of standard technological needs. The friction of everyday management of the full enterprise has increased, putting strain on the IT and support staff as well as users, as well as increased costs across the board. Now, in this presentation, I'm going to specifically break down the risks that an organization faces and how to assess the costs associated beyond the basic bill of services. Because it's not just the price of the software and the price of the solution that you're paying for. Now, let's start with some numbers. According to studies last year, 90% of IT professionals believe remote users pose a risk, and 36% reported a remote employee was the cause of an incident. And in our recent 2020 cyber hygiene report, organizations surveyed said they are most confident about cyber hygiene for on-premise systems and SaaS applications. But remotely located and mobile systems cause the most concern because they are harder to reach and aren't handled well by legacy patch management and hardening solutions. I cannot wait to send those same questions out to those same people at the end of this year to see how they had addressed and pivoted in this time. Now, their confidence in the on-premise access is for good reason. Endpoints that are within the confines of the corporate offices are easily protected by the layers of security around the infrastructure. You've got firewalls and gateways, as well as access for the IT teams to provide software support, patch management, and enforcing local policies, as well as training. The digital barrier has created a safe perimeter for the day-to-day in the office. But as organizations have started to adapt to this new reality of remote working, the architecture of support has not. When these endpoints move beyond the office walls, the configurations and access needs get complicated. To get through the barriers, these now remote and roving endpoints need to be configured, provided with VPN software, and provided the access that they had within the office itself. But none of this is new to you or me or any of us. This is how it's been for decades. And each OS requires a different setup, tools, and workflow. It just gets complicated. This doesn't even take into account third-party applications, their maintenance needs, or even the basics of software inventory audits. These layers of access control and security are well established for a reason, because they have worked. But on the flip side, they were not designed for what is happening today with remote working. The perimeter that was around the corporate offices have now expanded to the far reaches of the globe, and so with it have the cost. The strain on the architecture is constant. And the reality is that where there are barriers to success, people will try and work around what is slowing them down. We all know that. In this standard setup that we see here on the screen, the traffic from all those remote endpoints would be going down a digital funnel, big at the top, but squeezing for space towards the bottom. And as traffic starts to bottleneck into the corporate devices, access begins to slow down. With the new with the new reality of remote working putting VPN fleets to the flames, organizations may find their solution for their occasional remote workforce may not be able to bear the burden of the entire workforce. If VPNs fail to deliver enough bandwidth, organizations will quickly face a situation where employees are unable to connect, or worse, refuse to connect to a corporate VPN. This introduces a host of challenges from securing and maintaining the organization's infrastructure all the way down to ensuring even the basics of cyber hygiene and endpoint hardening for the remote users. When you take into account all the services needed to support this changing environment, it can get overwhelming. From security to endpoint hardening, inventory to help desk ticketing, remote access and digital meeting spaces, the complications are endless. And with technology diversity at an all-time high and each user connected through different routers, ISPs, and home configurations, the time to remove the friction is today. Now, no matter what OS or third-party software your organization uses, updating the software to protect against vulnerabilities is part of the everyday process. Each OEM has its own deployment schedule. Some once a month, some of them update more or less frequently. And even in recent months, those established patterns have been broken with more out-of-band updates and releases to support customers globally. Now, the numbers here, they can get a little worrisome. On average, it only takes about 5 minutes for an endpoint to install a patch and reboot the systems, but organizations were reporting upwards of 102 days between the release of the updates and deployment to their endpoints. Now, to put that into perspective, in 102 days, I can plant a corn seed, nurture and grow it to a corn stalk, harvest it, cook it, and serve it for dinner for my whole team before the enterprises are even getting around to determining what endpoints needed patching. And with 22,000 new vulnerabilities every year, that's about 60 per day, that's putting some major gaps in the organization's security. Now, with all this friction in place, with all these costs in place, adaptation becomes more difficult. No matter the processes that exist, from patch management, help desk ticket response, security, the time to respond is crucial to any enterprise, no matter their size. Now, with the previous data at hand, do you think your organization is prepared in this high friction, ever-changing world to respond with speed? I really want you to think about that. Are you ready to respond to the latest critical vulnerabilities? Given the time at weaponization is 7 days, that is effectively giving you 72 hours to harden your systems before you can expect to see a new exploit technique surface. Now, outside of this threshold, hardening becomes a reactive exercise with little to no pre-incursion value. This 72-hour mean time to hardening objective is where best-in-class SecOps and IT management organizations need to be working towards. And I understand it's difficult. Testing and rolling out mitigations in an accelerated yet methodical manner. But doing so with bandwidth and legacy solutions that are cost prohibitive is making this next to impossible. Now, thankfully, 0 days are the statistical exception rather than the observed rule of thumb in terms of vulnerability disclosures. And in fact, they account for less than 0.1% of the 20,000 vulnerabilities we see accumulating year over year. But when they do occur, the best-in-class response window is within 24 hours of disclosure. While this whole 24-hour, 72 mean time to hardening is ambitious, it's the pace that your organizations needs to move to realize a pre-incursion defensive is effective. This mean time to this mean time to mitigation of vulnerabilities needs to apply to all endpoints, not just the ones within the office walls. But the statistics show that remote endpoints are often left behind in the patch cycle. That clearly cannot be with all these changes. So the question begs, what is holding organizations back from getting ahead of this race? What technological situation is holding us all back? I'm going to pull out a quote directly from a support document. For decades, the support of remote users and machines has played second fiddle. leading to long-established policies growing beyond the scope and capability of the modern world. And even as legacy products grow, their foundational workflows often remain the same, leaving users with more work to solve what should be a simple issue. Now, in our 2020 cyber hygiene report, participants reported that only 42% are actually able to patch within 3 days and 15% within one. This points yet again to the special challenges of patching and hardening remote endpoints. Legacy endpoint product capabilities have increased limitations beyond the non-corporate networks. So let's look at what the big picture of what we're all up against. Research shows that unpatched vulnerabilities are directly responsible for up to 60% of all data breaches. The number of security professionals who forego patching vulnerabilities to avoid disrupting the workplace is staggeringly high. Over 80% say they've postponed a patch for this very reason alone. And another 80% of CIOs and CISOs say that they have been shocked to discover that a patch or update that they thought had been deployed across their network actually hadn't been, leaving multiple endpoints vulnerable. Now, again, this data is from 2019. Before this sudden shift in the remote approach, we can only imagine what numbers we're going to see coming out at the end of this transition. With a 1 in 4 chance that one of the vulnerabilities may be exploited before you get around to patching it, it may not be worth the risk to your enterprise. And those chances are only going to increase if the foundations of cyber hygiene are not addressed early on for all remote endpoints. Minimizing your network's attack surface and being a smaller target is key, along with the need to do so in a financially sustainable manner. Without continuous ongoing cyber hygiene, the exploitable attack surface on the remote endpoints may expand to the point where they are easily compromised. And all it takes is for one to be the gateway to allow for lateral movement through your whole network. This is an unacceptable price to pay because endpoints aren't connected directly to the corporate network. Now, if remote endpoints are the new norm and trying to shoehorn them back into the corporate network to manage and secure them isn't working, what is the answer? Well, it's not this. This is the standard approach. And while organizations continue to invest in advanced technologies in other areas of their security stack, the basics of endpoint hardening are still being handled by legacy solutions. And that legacy approach to cyber hygiene is broken. From the day-to-day of policy enforcement across all managed endpoints to managing and deploying critical patches, there are too many tasks that are relying on organizations actively monitoring security update sites for the products that they're using. Just think of how many pieces of software you have in your infrastructure right now. Think of all the different operating systems. Think of all the different endpoints. Think of the technological diversity and complexity that you're managing. And when critical security patches are released, most are scrambling to pick and choose which ones they're going to deploy and when. Then they have to download the deployment servers for staging and run tests against their infrastructure to make sure it all works. After that comes the onslaught of updates being manually deployed out, all without confidence that it worked 100%. The situation does not even take into account the securing of machines that are remote, multiple locations, or even just offline. And even more often, enterprises are filled with a mix of operating systems, meaning this work has to be replicated multiple times across multiple products. IT departments and security teams are generally already overwhelmed with too many separate tools and too much on their plates. There are simply too many one-off tools with manually driven workflows and too much legacy technology that is painful to deploy and maintain with costly on-prem infrastructure. When it comes to this, when it comes to these on-premise solutions, there's a significant amount of cost and complexity involved as well. Organizations need not only to purchase, build, install, and maintain their own servers, they also have to act as their own staging servers, pulling patches down from vendors and deploying them through their repositories. When it specifically comes to cyber hygiene, 74% believe that they can't patch fast enough because they don't have enough staff. Consequently, 64% are planning to hire dedicated resources for patch management alone in the next year. And around 57% of organizations still use spreadsheets and emails to track and assign patching tasks. It's a lot. The economics of support is difficult to manage. With all the infrastructure, there's also maintenance. And every penny counts in IT. From the power consumption of the on-prem servers to the time it takes the patching team to go through all the steps to deploy one single update. Every time a vendor updates their product, there's something new for an organization to download and install. From there, organizations have to deploy agents, which can be big and clunky, and they have to do so multiple times so that they have infrastructure in different geographic locations or contrasting types of endpoints. Adding to the complexity that is constantly maintaining and updating your infrastructure, organizations actually have to patch their on-premise patch management servers, not using a patch management solution that they purchased. They have to do it manually. All of this has massive implications on the amount of labor being invested, capital expense, and the maintenance friction of on-premise approaches. These are costs adding up. So many parameters and elements play into calculating the cost of the service, and it seems just handling the basics of cyber hygiene has become an acceptable time consumer. On top of the investment of the human element also comes the need to build and maintain all the servers, purchase additional software like VPNs for remote users, and ultimately trust that any remote users are actually logging into those VPNs and following the established procedures. The demand on the workforce, the demand on the wallet, not to mention the on-premise servers, deployment nodes, and other tools just cannot match the economics of scale with a legacy approach. Now, on average, what we have seen, 38 hours is dedicated through legacy products per week to deploying patch updates and software. On top of that, those teams are also maintaining that on-site hardware and software and having to go through at least 40 hours of training per employee. Per the recommendation of most vendors, 40 hours of training. That's 40 hours that an employee is not working. This is not helping it. Now, so many parameters come in, and elements play into calculating the cost of a service. It seems that it's just overtly expensive. We have the cost of the employee, the maintenance hours, the product training, the number of employees, with all the infrastructure that goes into it. So let's just say we have an environment of 1,500 endpoints, all of which are remote for obvious reasons. We've got 5 staff to manage. We have 6 geographic locations and 50 servers. And if we take into consideration the $82,000 average IT salary plus the 20% corporate burden rate, we get $51 per hour. Starting to see these hours add up, right? In a legacy environment, it's not just a simple few clicks to get to a solution. Calculating the time needed to learn the products and managing script out deployments, working with multiple consoles and agents, and the on-site maintenance cost of deployment and management servers, the VPN cost, this environment of 1,500 endpoints would be spending over $299,000 a year just to handle the basics of cyber hygiene. That's a lot of money. I did the math. I just love this GIF. I'm not gonna lie, I had to throw this GIF in. Now, if we take that same environment and apply a cloud-native SaaS-based solution, we're gonna see those costs go down. Take away those on-prem servers, the necessity for a VPN for patching and endpoint hardening, costs associated with managing individual geos, and the need for multiple consoles and agents. Take away all those elements, those barriers, those costs adding products. We're going to see a savings of $190,000 in the first year alone, over $190,000, up to 202. Imagine what your team could do with that money and the time back in their pocket. That's the whole point of this thought process. If the friction and costs exist due to outdated policy or technology, and it's costing your organization more money, and adopting a modern approach would solve for many of those issues, isn't that the reality that you would want to exist within? One where the ebbs and flows of corporate assets and needs are met with a flexible, robust solution with predictable costs? And if we have adopted this approach in so many other elements of our corporate work, why would we not want to apply it to the fundamentals of endpoint management? Imagine a different remote endpoint management reality where you had no infrastructure to update or maintain, and you could deploy anything to your endpoints without worrying how it gets there. Just a few clicks. Where you always had an up-to-date inventory of your systems and can manage them wherever they are and however they are connected. Where you could get the latest and greatest features without having to update anything on your end. Where you'd have all the impact and control without the heavy burden on the endpoint user or IT team. We're all familiar with tools that fit into this category, from our email systems to data storage. This isn't a new reality for a lot of our technology needs. The challenge here is to move further beyond the legacy procedures that have been in place for decades, to move beyond the exponential costs that just are not up to the challenge today. In order to remove the friction, it's now more important than ever to adopt and implement globally available cloud-native services. Doing so will remove the biggest barriers to managing endpoints, access, and control. Moving beyond the on-premise policies and architecture that's slowing down your employees and their work, bottlenecking your data access, provides the capabilities needed for any IT team to scale with endpoint hardening needs. And like any other critical software as a solution, the ongoing maintenance and security for remote work is best serviced through highly scalable and always connected cloud services. After all, remote users are always connected to the internet, just not necessarily to the corporate network. By making a secure, globally scaled SaaS always available to them, organizations can maintain can maintain continuous visibility and control. It's not time to ditch VPNs or zero trust or any of those access controls. That is not what I'm here to say. Instead, it is time to establish perimeters around the individual endpoints, closing the gap in not just security, but management, while enabling your IT team to maintain visibility and engagement, no matter where the machine is in the world. Simply put, it's time to treat each endpoint equally. With that, I'm going to stop talking and I'm going to pass it over to my good friend, Jay Goodman, for a quick demo on automation. Jay.
All right, Richard, are you able to see the console here?
I can.
All right. So my goal here is to kind of get everyone a little bit more familiar with the Automox console. We're going to look at a little bit of what we can do for device and application inventory. Then we're going to create a patching policy and show you how to apply it, how to introduce some automation there. And then we're going to use Automox to actually deploy software to an endpoint and verify that it got deployed appropriately. And then finally, we're going to kind of close out with looking at how you can use Automox to improve your cyber hygiene using our worklets to manage configurations. All right, so getting started, this is the console that you get a view of when you log in. It gives you a quick dashboard view of your organization, high-level overview of the statistics, how many updates are scheduled, whether or not you have any manual approvals that need to be taken care of. It just kind of gives you an idea as to where you stand. From here, we can actually dive into devices. And from the devices pane, we get a quick list of everything in your organization that's managed or unmanaged. And you can quickly sort and filter the groups here. So for example, if I want to look at only Mac endpoints, I can quickly filter down to just that. So from here, then we can actually dive into an individual device like this. This is a desktop that I put in here for testing. This gives you a whole bunch of information about the actual device, including the system information, disk space, the OS build, any network information. And really from this console, we can see a lot of what's going on and we can quickly address some of that. From here also, we can kick off a scan on the device. So I'm going to do that now so we can see in a little bit whether or not we need any patches on this device. If I back out to devices quickly again, this is actually where you can also quickly add devices to the console. So from here, we can add Mac, Windows, or Linux. Windows will give you an installer that you can use with your typical package manager. With Mac or Linux, you can either do the actual installer, or you can actually run a curl command, or it'll give you the curl command to install the agent. So let's get into the meat and potatoes of actual automation, and that's done really within our system management interface here. From here, we can control all the actions and policies from the endpoint using the lightweight agent on the system. The agent actually runs as a background service and requires no actions from the end user. It's actually more or less invisible to the end user. Through this pane, though, we can group devices and apply patches and create individual groups. So, for example, let's take a look at apply critical patches. And we can see here that critical patches is actually only assigned to a couple of things right now. If we want to expand where that's being applied, we can quickly click on assign, and we can actually save that. And now on the next check-in from those devices, they'll start to apply critical patches. So let's actually take a look at creating a policy. So right up here, we're actually able to create the policy. Um, let's just say we want to quickly patch everything. We just want automation to, take the controls, and we don't want to deal with anything. So first, we have to just name the patch policy. Then we have to give it a status of either on or off. Obviously, we're going to want on. And then if the patches require reboot, we can choose whether or not to automatically reboot. So we're going to click yes for this one, because we really just want to make sure we get everything up to date and patched as fast as we can for this. So down here during scheduling, we can pretty granularly decide when we're going to patch, which days, which months. We can even choose specific patch windows. So if you have mission critical servers that only have a very specific patch window, we can meet that window. So for this example, though, we're going to patch everything at midnight. We really want to make sure everything gets patched. And we can also set up notifications for users, as well as the ability for them to defer their patching. So you can actually customize the message for Windows and Mac individually, and you can give them specific deferment options. So you could say, we're going to allow them to defer up to 3 times for either 1, 2, or 4 hours. So each time that this patch policy comes up, it's going to give the end user the option to choose whether to patch it now, or for the first 3 times, it's going to allow them to choose 1, 2, or 4 hours from now to remind them again. So we got this policy ready to go. Let's go ahead and create it. And there we go. We've got our patch all. Now we're going to have to assign it to a group. We're going to assign it to this newly added devices group for this demo and save it. And now we can quickly check, and we see that this policy is now assigned to these newly added devices. And we can actually execute the policy now if we wanted to. I'm going to hold off on doing that because I don't want this to reboot that system quite yet. So that's basically how creating a patch all policy would work. The next thing we're going to kind of go through is, how to actually deploy software. Organizations have many different softwares that they might want on a system. We support patching a lot of different softwares, but sometimes you might actually want to have something specific on your systems. So we're going to go back to creating a policy. From here, we're going to create a Windows policy for this example. And I am a huge fan of Notepad++. So we're going to create a policy for Notepad++. And we're going to install it on everything. I see the question of, do we need a WSUS server to run this? No, we do not. This actually runs directly from the cloud. We can use your on-prem WSUS server if you want to have like a trusted source for patches, but there's no requirement for that. And that really is what allows us to extend way beyond the scope of your VPN. So you don't have the requirements for an endpoint to check in on a VPN. None of these systems are in a VPN right now. So getting back to the deploying the package, we got to identify the package. So for this, you need to put in the package name. So the package name is the Notepad++ 7.8.6, and we have to assign it the version number. And then we actually have to give the system the file. So here's the installer. I'm going to put that up. It'll take a second to load into the environment. There it goes, and we can see it there. It's ready to go. Now, if we wanted to, if your software requires command line variables for execution, you can put those in here. But Notepad++ is pretty reliable and simple. So we're just going to go ahead and deploy it on everything every time it checks in. And what this will do is that that doesn't just mean it's going to deploy it once. This also means that I might really like Notepad++, and I might really want my A users to always have access. This policy is going to make sure that if they uninstall it, this is going to put it right back there. See, obviously, the implications are with a security service or some sort of monitoring service. You can enforce that software is on the system, whether or not the user installs it themselves. So we're going to create this policy. And again, we've got the policy here, and we're going to assign it to this newly added devices. We're going to save the changes. And this time I'm actually going to I'm going to execute this policy now. And what this is going to do is it's going to install Notepad++ on all the devices in my newly added devices group. All right, so we're going to give that just a moment to run. And while we're waiting for that to run, we're actually going to go and look at a worklet and creating a worklet. So a worklet within Automox is the ability to push a script, either PowerShell or Bash, down to the endpoints, and it allows us to get a lot of granular controls. There's a lot of different things that we can do with this, but for this demo's purpose, we want to enforce password policy. And my spelling is horrible. So what's going on here? Right now, we're just naming the policy. We're just going to name a name that we know what it's going to do. So next, we have two blocks of code. We have an evaluation code and a remediation code. Evaluation code basically is the PowerShell or Bash script to check the endpoint. So you can check first to see, like, is the policy set to, or is the configuration set to X. For this particular example, we don't really need to check. This is a compliance issue. We're just going to enforce. So we're going to put in exit 1. What this does is it exits the evaluation code saying, make sure it's make sure it's compliant. Just do it again. So every time that this worklet runs, it will check, or no, it won't check. It'll just enforce these the policy within the remediation code. So within the remediation code, we're going to put in a little bit of code from our CIS buddies. And what this does is we're going to ensure that account lockout duration is 15 minutes. And we're going to set it so right now it's set for 10 or more invalid login attempts creates the lockout. So what we're going to do here is we're going to go down, and we're actually going to set this to 5. We really want to have better security for our remote endpoints. So we're going to go ahead and set that. We're going to again select all, because this is a policy we really want enforced on a daily basis. If the endpoint or if the end user changes their password policy, we want to make sure to roll that back to the policy that's in compliance with our security operations team. So we're going to create this worklet, and now we've got this worklet that'll allow us to assign this password policy to any system we want. And in this case, I'm not so worried about my managed on-prem devices. I am really worried about my remote devices. So I'm going to go ahead and assign this to my remote devices and save the changes, and then execute the policy. I don't necessarily have to execute the policy each time. The policy will execute on the next check-in from the agent, but in this case, I really want to push this out right now. I want to make sure everyone's up to compliance, and this allows me to during the day, I can actually push this down to those endpoints whenever I need to. So that's basically creating a worklet. So we're going to go back now and take a look at the systems that were that I wanted Notepad++ installed on. So we can actually go in. We can see that, yep, Notepad++ is deployed, or the policy is assigned to this system. We've scanned the device. It is pending some updates, so it's probably Windows updates that just came in. But what we can do now is we have a software inventory down here. And what we're going to do is we're going to check and see if Notepad++ got installed. And so here we can actually see on this device, we do have Notepad++. It's installed and it's up to the current version. So we're good to go. It successfully deployed Notepad++. So now let's take a look at software, the software tab. So the software tab is really a software inventory of your entire organization. And it does, from here we can actually do the Notepad check as well. And we can actually see that, it's on device. It's on 2 different devices within my environment right now. That's pretty typical. I like Notepad++. It's a good software. But the other thing we can do from here is, let's say there's a new CVE that gets, and we want to make sure, or we want to check and see what is our exposure. Like, are we at risk? Especially for something, a 0-day or a critical vulnerability that we want to, as an organization, patch within that first 72 or 24-hour window. Let's go ahead and take a look at CVE 2020-0601. So searching for this, we can actually see that, we have 2 systems, or 3 systems actually, in our environment on 2 different builds of Windows that are potentially at risk. And this quickly shows us that all the systems that would be at risk from CVE 0601, and we can see, well, there's actually no impacted devices, which means that all my systems that would be vulnerable to that vulnerability are up to date and patched. If they weren't, right from this interface, we can actually kick off the patch, so we can get everything up to date. So this really gives you confidence as an IT or security operations admin, that not only are your systems being patched, but you can actually check and correlate. Is the patching done with the CVE that's that's causing a vulnerability? So, wrapping things up, here's what we looked at today. We took a look at how to view the inventory of your organization's devices and software. I showed you a little bit about how you can automate your patching with granular policy controls. We can actually do both patch all policies, as well as we can actually do complex logical policies. It depends on what level of complexity your organization needs. I've shown you how you can deploy software to your endpoints using Automox, and then verify those installations within a matter of minutes. Like we were able to take Notepad++ and push it down to a ton of one endpoint. We could do a ton of endpoints, but we pushed it down to an endpoint and then verified the installation. We also looked at how Worklet can be used to improve your endpoint hardening by managing the password configuration of your endpoints remotely. So there's no requirement for a WSECM or VPNs. We can actually just reach directly out through the agent to those endpoints and remediate. And finally, we looked at how we can use Automox to quickly triage a new vulnerability to give us a full understanding of our exposure. And the best part about this all of this functionality you saw today can be accessed through our API. So if you want to bake this into your systems, we can do that. All right, we've got a couple questions, it looks like.
Hold on, I've got another slide. Don't be jumping to my slides. Yeah.
I guess I'll pass it back to Richard then. Thank you.
There we go. Thanks, buddy. Let's get this. Let's go back. There we go. So ultimately, what we're talking about is an endpoint management tool built for the modern era. What Jay just demoed right there, the Automox endpoint hardening solution, has been designed from the very beginning to specifically address the pain points of legacy approaches, challenging the norms of the workflow, architecture, console access, and remote endpoint support. We've changed the game when it comes to proactive endpoint security and management by providing IT teams the capability to patch and manage their Windows, Mac OS, Linux endpoints, no matter where they are in the world, all without the need for on-prem deployment servers and infrastructure, VPN connectivity, and complicated workflows. Our cloud-native console enables IT teams to respond at scale to newly revealed vulnerabilities, just as Jay just did, manage third-party software deployments and updates, local endpoint configurations, and create and automate patch deployments and custom policies, and so much more. In order to strategically partner with SecOps and IT ops, they must be equipped for success. That requires the cyber hygiene automation platform that delivers inventory management, that can get full inventory of regular software and hardware audits, report for compliance, and giving a clear picture of every endpoint in your managed network, including internal and remote, that can deploy through managed software policies, giving you the ability to control third-party applications installed on all managed endpoints. A console that allows for configuration, built-in hygiene fundamentals, all from a single console. Admins must be able to deploy these elements with ease and fully automate actions by adding work tasks to the policy baselines that are continuously enforced. Now, not only does this cyber hygiene automation immediately reduce 80% of vulnerability exposures with minimal effort, it also keeps configuration drift from ever occurring in the future. Gives you the capability of worklets. Name one company that has worklets. It's us. Ability to go beyond the roadmap of what we have defined for the product, as well as straightforward reporting. We want you to have a clear, concise picture of what your endpoints have going on. Being a smaller target is great, but you need an easy and compelling way to show the business and external auditors that your best-in-class practices is achieving the expected outcomes. All of that from a cloud-native console. I'm going to leave one quote before we get into the Q&A. I think it's a great quote. Sometimes cloud-based applications are just better. You don't have to manage the infrastructure. You get the latest and greatest features, and you don't have to deal with the headaches of maintaining it. It comes from Adam Todd, the director of IT operations at Cook Aquaculture. I think it's pretty pointed and relevant. So let's get to the Q&A. We've got some good ones coming in. Jay, you want to take it on?
Sure. So one of the questions is about what can we do other than software patching? That's actually what I kind of showed a little bit. We're not only a software patching tool, we're really kind of an endpoint management tool of sorts. Like we're able to give you an application and device inventory on the endpoint or on all your endpoints, as well as configuration management and scripting. We can do all of that from our console. And then we also have reporting functionality on all of this. Let's see, what other questions
We've got another one. What if the cloud servers, what if the cloud services server experiences an outage or loses service? If we have an urgent patch, would we be at the mercy of that server?
So the benefit with a cloud service is that we are not reliant on a single server. We actually have everything is run on at least 2 servers for high availability, which means that even if the primary server fails, we have at least one backup. So we very rarely have any sort of outages that would impact your ability to patch your endpoints.
Awesome. We've got, let's see, I'm going through this. I'm not sure if I'm comfortable with fully automated patching. Could I potentially continue using manual patching workflow? I mean, that's a really relevant question.
Yes, absolutely. So that's actually within the dashboard showing as you are able to, you could do a fully automated patching solution. Otherwise, you could also do a manual approval patching, which what that does is it allows our agent to automatically identify the software that need or software or operating systems that need to be patched, and it'll give you a list of those systems that you can then decide when and how to patch. So you have absolute granular control. In addition, like I said, we have advanced policy creation, which allows you to do some very, very very customized logic-based rules around patching. So we can go all out and just patch everything automatically. We can take it all the way to fully manual, with our system basically just being the point or being the way for you to extend your reach to those systems. Or we can meet you in the middle somewhere and find a set of rules and policies that allow you to take just the control that you need to.
Yeah. And one final question that just popped up. Can Automox deploy any custom software? Yes. If it's an executable or a file that can be executed on the Mac, Linux, or Windows, it can be deployed out through our console. Very simple to do through the workflows. You can automate that through the groups or do a one-off, as Jay so happily showed with his Notepad love
I
in
love
that demo.
Notepad plus plus. This is solid, solid software. But to add to what Richard said, not only can you deploy any software, but we allow you to have those command line arguments. So if you have, say, a user key that you have to put into the software, we can do that from our console. There's not just an executable only component. We also have the ability to tag on any sort of PowerShell scripting that you need to with that software deployment.
Yeah. And you can even uninstall it if needed. So if you're deploying out a software solution, say you're switching endpoint protection products, your AV product from one to another, you can do in your automation script on installation and for the first component in installation of the new product, all automatically and enforceable so that no matter what, you know that you are up to date and you have the software deployed out to it all. Looks like that was the last of the questions. Give it a quick second for any more that come in. Not seeing any. Awesome. Well, ladies and gentlemen, again, we do appreciate you taking time out to spend some time with us, learn about the TCO of automation and the cloud native consoles. You can find us. If you have any questions, you want to reach out to us, connect to us socially, you can find us on Facebook, Twitter, LinkedIn, Instagram, and Spiceworks. And on top of that, we have our own community, Automox Alive. You do not have to be a customer to join up with that. Go to our homepage, you can look for Automox Alive link, join the community. You can see what other customers are doing with our products. You can see how they're using worklets. You can see how they're using the feature extensibility and cloud native controls to manage their endpoints. Ultimately, we want you to move beyond the legacy approach. We want you to save some money. We want you to get to a strong mean time to hardening. My name is Richard Malik. Thank you so much. Jay, say goodbye to the beautiful people.
Bye, and install Notepad++, solid software.
Thanks, everybody. Have a great day.